Uh, Very good to be here, and what I have to say follows neatly from the presentation you've just heard. Sorry for all the disruption that stops us meeting in person, but hopefully we can learn to communicate as well through these mechanisms. And we've all got a very strong interest in the world getting on top of the current problems quickly. Last November, I published a book called Superpower, Australia's Low Carbon Opportunity, in which I explain that Australia has exceptional opportunities in the emerging zero emissions world. And a lot of these opportunities are associated with a potential for low cost production through zero emissions processes of metals from Australian mineral ores. In the high carbon industrial economy that has been at the heart of global economic development since it all began a quarter of a millennium ago, Australia has very rich endowments. We are by far the world's biggest exporter of coal when you add together metallurgical and thermal coal. We are now the world's biggest exporter of liquefied natural gas. And these abundant resources have been the base of substantial minerals processing industries. We are by far the world's biggest exporter of iron oxide ores for reduction into iron metal. By far the world's largest exporter of aluminium oxide ores for smelting into aluminium metal. We're also a major source of a lot of other minerals for processing. Most of our iron ore, most of our aluminium ore, most of our other mineral ores are exported in unprocessed form, although despite the abundance of local reduction agents, metallurgical coal, and sources and fossil sources of energy. But nevertheless, we have substantial export industries for a lot of these metals. For a while, 1980s and 1990s, Australia was the biggest exporter of aluminium metal. That slipped back in recent years. I did a major report for all of the governments of Australia, the federal government and state and territory governments, about a dozen years ago, in which I discussed the contribution that Australia would have to make to world decarbonisation as we got on top of the problem of climate change. And back at that time, I pointed out that there would be significant costs to the Australian economy in the early decades from the transition, partly due to higher costs of energy, partly due to loss of competitiveness in some industrial processes. And all of that would be necessary for us to accept, because the costs of not dealing with climate change, the costs of unmitigated climate change would greatly exceed the costs of Australia doing its fair share in the global effort. Since then, I've followed closely the changes in the costs of various elements of the necessary industrial and energy transmission. And the story I tell in the book Superpower is that cost changes have been so substantial that the transition in Australia would not involve substantial costs any longer in the early decades, and it would lay the basis for Australia becoming a stronger participant in global production of energy-intensive manufacturing, to the extent that we could call Australia a superpower of the emerging low-carbon world economy. So Australia is rather uniquely placed in the world. It's the richest of the developed countries in old fossil energy and reductant resources in the high carbon economy. In an economic sense, of course, it's resources relative to domestic demand and population that determines comparative advantage in international trade, and our natural endowment of coal and gas is immense relative to population and the size of the domestic economy. But we're also distinctively the world's largest the domestic economy in the zero emissions world. The combinations of high quality wind and solar resources in many parts of Australia are incomparable globally. And that means that Australia is naturally the low cost source of energy in a world in which everyone is relying on zero emissions sources of energy. Australia is distinctive in a third way. Of all the developed countries, we are by far the most vulnerable to climate change. And I pointed this out at some length in my big report for all of the governments of Australia 13 years ago. We're very vulnerable because of we are already an unusually hot and dry continent. We're the driest of the continents other than Antarctica, and the southern latitudes of Australia will be threatened with lower rainfall as wind systems drift south with warming. And being the hottest of the continents, a lot of Australian agriculture and other economic activity is at the margins of temperature beyond which current technologies run into very large problems. So we've got the strongest interest in the world moving to a zero emissions economy. We were the best endowed of the developed countries in the old fossil energy economy, but we're the best placed to do very well in the zero emissions economy. So this makes the issues of energy transition, industrial transition, rather centrally important to Australia's future. Well, what changed between my report in 2008 and today? Well, the most important thing that changed was a very large reduction in the cost of renewable energy from renewable energy resources of any quality, of any given quality. When I did my very detailed modelling of how the Australian economy would react to the need to move to very low emissions through the 21st century, after consulting with all of the scientific groups and the business groups that would know best, not only in Australia, but internationally, I wrote into my modelling then an assumption of the costs of solar photovoltaic power falling by a few percent per annum. Well, in fact, what happened was that costs fell by more like 15% per annum over a decade, so the total cost fell by 85% of the cost of equipment for photovoltaic power over a decade. Also, there was an historic fall in interest rates over this time, the fall in the cost of capital. And this systematically reduced the cost of renewable energy relative to fossil energy. This is a really powerful factor. What's happened to the cost of capital is unprecedented in economic history. with real interest rates for low-risk borrowers being around zero now. Rarely in history were borrowing costs for low-risk borrowers much less than around 5%. Costs were already coming down in the early years of this century because of a tendency for global savings to rise more rapidly than global investment. And these trends accelerated after the global financial crisis. And for a number of years now, we've had fluctuations in interest rates around zero in real terms, currently well below zero in real terms in a number of countries. Renewable energy is almost all capital costs, wind, solar, but also the technologies that are necessary to firm solar and wind, to firm intermittent energy, to turn intermittent energy into energy available anytime. Battery costs have come down, but batteries are all nearly all capital cost, rather low recurrent costs. The costs of pumped hydro storage have come down, not because of technological change, but because of their capital intensity and the reduction in the cost of capital. Similarly, renewable energy costs have come down, even given any given costs of equipment because of the reduced costs of financing. And the cost of renewables have come down more rapidly than the cost of fossil energy because a very high proportion of the cost of coal-based or gas-based or oil-based energy power generation is recurrent cost, the cost of the raw material. So the fall in the cost of capital has systematically favored the new energy over the old energy. Similarly, if you're using hydrogen in reduction processes, the costs are mainly capital costs with relatively low recurrent costs. So for all of these reasons, the cost of the energy transition to zero emissions has come down a lot, and the costs of the transition to the zero emission economy have come down. And the relative competitiveness of economies which have rich renewable energy resources has improved, and Australia foremost amongst them. That's the story of superpower, Australia's low carbon opportunity. Well, the world as a whole is committed to going to zero emissions. That's a clear implication of it's an explicit commitment under the Paris Agreement, a clear implication of the 2 degrees and as close as possible to 1.5 degrees objectives, is that we'll have zero emissions by mid-century for the world as a whole, earlier than mid-century for developed countries. We won't reach the Paris goals unless we achieve that end. Pressures for temperature increase will continue to arise while emissions are above zero net. So there will be increasing pressures on the world to achieve that zero emissions goals as the effects of climate change become more evident. We're already seeing that recently. We've got some recalcitrant countries who aren't facing up to the realities that atmospheric physicists are putting before us. We have an American president who has sought to withdraw from the Paris Agreement, but it's unlikely that in a great democracy like the United States, that denial of science will be viable for very long. So I expect the current stance of the United States administration to appear in history as an aberration. Let's focus on a couple of the big opportunities for decarbonising metals processing with implications for Australia. Decarbonisation of manufacturing generally is going to involve in various combinations one of three different processes. One is the electrification of industrial processes. That often when the role of energy is to provide heat, that you can provide heat from either combustion of fossil energy or through electricity, and electrification will be an important part of the process. A second route to decarbonisation of industry will be the use of hydrogen made from zero emission sources, either from electrolysis using renewable energy or through carbon-based processes with capture and storage, geological storage of the emissions. Generally, I think it's going to be very hard for carbon capture and storage into geological structures to compete with hydrogen-based processes, but there is likely to be some favourable location or locations where you've got very good geological sites adjacent to industrial activities where costs are lower and where CCS may be able to compete. But I think that the economics are likely to favour the hydrogen route from renewable energy in the long term. The third element in the industrial transformation is going to be the use of biomass as a renewable source of industrial raw materials rather than fossil hydrocarbons. And it happens that Australia is unusually richly endowed in opportunities for low-cost biomass because of our very large areas of woodlands per head of population, especially in areas that are less well favoured for agriculture than, for example, the agricultural areas of Europe or China or North America. Steel and aluminium are going to be particularly important in the industrial decarbonisation process. Emissions from the reduction of iron oxide into iron are about 7% of global emissions. That's huge. Australia is by far the largest exporter of iron oxide. It provides about 70% of the immense import requirements of the Chinese steel industry, which in turn accounts for nearly half of global steel production. The low-cost route for zero emissions production of iron for steel making is, as I've mentioned, likely to be the hydrogen route. Hydrogen will be produced at relatively low cost in those parts of the world with very rich combinations of wind and solar resources, and Australia is foremost amongst them. And it's going to be much cheaper to use hydrogen domestically for minerals processing than for transporting it internationally, partly because, well, mainly because the costs of international transport of renewable energy are going to be very high. You can move it through high voltage direct current transmission between continents, and there are two major projects in Australia for exporting Australian renewable energy, one to Indonesia, one to Singapore. These will probably happen, but it's not going to be cheap power at the other end. Similarly, hydrogen, whether through liquefaction, or ammonia, use a lot of energy in the preparation of materials for transport, and in the case of liquefied hydrogen, is expensive to transport itself. So it's going to be very much more expensive, twice or more as expensive to use Australian-based hydrogen, whether through the liquefaction or the ammonia route in Japan or Korea, or for that matter, Germany or France, than in Australia. So the economically rational process will be to use Australian renewable energy to reduce Australian iron oxide into metal here at home. In aluminium, the process is a simpler one. Already, the process is an electrified one. So it's a matter of producing competitively renewable energy. Already in Australian electricity in the right locations, combinations of solar and wind is cheaper than the cost of coal alone in our big coal exporting states, Queensland and New South Wales, the coal alone being used in power generation. So there'll be no more investments in Australian coal-based generation. The existing coal-based generators in Queensland, New South Wales and Victoria will shift to use of electrical energy and be competitive and expand, or they'll remain reliant on coal generation and die over the next decade. Might leave it at there, and happy to answer questions.
Right, thank you very much for that very thorough taking us through the opportunities as you see them. So Bassam has the microphone. Do we have any questions of Professor Garnaut? Or was it really thorough?
Yeah. Thank you, Professor Garnaut. It's Leighton from Adelaide University. I'm a great fan of your book, Superpower there. I would recommend send those books to all the politicians there. I think the chief scientist, Alan Finkel, also recommended that we should go to this zero carbon economy there. However, I don't know how we can convince all those politicians to go with that idea there. Thank you.
Well, fortunately, we have markets for many goods and services, and there'll be quite a lot happening through business decisions and participation in markets that in the end do not depend on political support. Although to get the new industries going, support for innovation will be necessary. We've seen that in the renewable energy industries. Today, our solar and wind are substantially cheaper when you take capital and current costs into account than old fossil generation of energy. But to get started, support from the Australian Renewable Energy Agency, support the early plants was important in cost down. The innovator, the first company to do anything, spends a lot on learning that is shared with the whole community, and so there's a strong case for public support for the innovators, the very first users of new technologies, and I think we do need governments to provide that initial support, arena type support for the initial zero emissions industrial processes. Once the lessons have been learned from the innovators, then it will be self-sustaining. So it's not up to politicians alone, but certainly political leadership and the provision of support for innovation could be important in getting it going. How do we convince politicians? Well, that's, in a democracy, that's the responsibility of all of us.
Right. Bassam, are we having questions a question online now?
Yeah. So we have two questions from Lina Hokde from Mintech, South Africa. She asked, with water vapor also being a greenhouse gas, do you foresee more research need in how hydrogen as replacement for fossil fuel will impact global warming? This is question one. And the second is about CCS, commercial CCS. What do you see as the greatest barriers to commercial CCS today?
There's so much water vapor in the air that the amount that is added by hydrogen combustion as part of a reduction of iron oxide is trivially small. So I don't think that's going to be an issue, and simply because of the quantities involved, the amount of water vapor in the air added to the global water cycle from hydrogen is not going to change the balances. Of course, if it was large enough, it would lead to more precipitation globally and a different water cycle, but with positive and negative effects. But it's not going to be large enough to have those effects. The barriers to CCS, well, the main barrier is it's going to be its cost. Now, not all CCS is the same. Where you have very well-known geological sites, for example, drilled out for gas or oil, and so you know precisely what's down there. And if you've got an industrial activity near those sites, costs will be relatively low, and that they may be economic there. Similarly, the cost of capture of carbon dioxide and its separation from other gases so that it can be put into geological structures varies greatly with the process. If you're making hydrogen from fossil fuels, for example, natural gas or lignite or coal, then you're going to end up from that process with a rather pure carbon dioxide stream. And so the cost of capture prior to storage is relatively low. If you capture power from a blast furnace, capture carbon dioxide from a blast furnace or a power generator is mixed with a lot of nitrogen in the air and other gases. And so the cost of capture and separation of the carbon dioxide will be very high. So it's more likely that CCS will be economic for processes that generate a pure stream of carbon dioxide, amongst them production of hydrogen. But as with application of the new electrolysis and hydrogen steelmaking technologies, we need support for the early innovation in carbon capture and storage, because the very first one will make it inevitably run into some dead ends. They'll learn a lot that we all share in the learning from, so that public support for the early plants, so that we learn those lessons from innovation very early, very important.
Thank you. Right, I think we've got time for 2 more questions. Keith has the microphone.
Keith Lovegrove, ITP. A question for Ross, but also for Cedric, if he's still online. Okay.
I am.
Oh, good. I think in this audience, I think we pretty much all share this vision of where Australia's future lies, whether it's value-added exports or ammonia or hydrogen fuels. That seems to be where the future's headed. What I'd like to ask both speakers is, if Australia's slow to act in this area, which other countries internationally are the competitors we have to watch out for?
Maybe I'll have a first crack, and it's the combination of solar and wind renewable energy is very powerful. It means that the costs of storage to turn intermittent energy into a constant flow is much lower. And when you've got an interruptible process like making hydrogen, then using power and electric arc steelmaking process, the costs are very much lower if you've got access to solar and wind. So that most of the time you've got low cost renewable energy without storage. And there aren't many countries that have those combinations. The Middle East has very good solar resources, but much weaker wind resources. Parts of Canada have got very good wind, but not solar resources. we're actually a fair way in front. Parts of South Africa have got combinations of wind and solar, Southern Africa. Parts of Southern Latin America have good combinations. For example, parts of the Chile coast with an additional advantage of very low-cost pumped hydro facilities. But Australia's actually very well positioned. But the implication of the question is a sound one, that there are places that even if they're not as well placed as Australia, could get started earlier than us if we don't get our act together. And there will be very big advantages for the first movers in these processes.
Thank you.
Can you hear me? I very much like what Prof Garnaut just said. I would simply add that really Australia has a unique position as an iron ore exporter to make hot briquetted iron in a very competitive manner. Maybe Morocco and Mauritania could also be close to that because they have very good solar and wind, and they have also lots of ores. Then you have a lot of countries that have good solar and good wind. He mentioned Chile. He mentioned South Africa, but South Africa must first decarbonize its own power sector, and that's a long way to go. In the Middle East, there are very good winds in Egypt along the Red Sea, and there you have a very good combination also of solar and wind. And finally, northeastern China with Inner Mongolia, with Hebei, and also Midwest US have also very good possibilities. So we have to take care of that. And finally, when you have wind and not so much solar, but wind and hydro, for example, that could also be a very good combination because hydro will provide much easier regular electricity output, which will reduce the cost of any hydrogen buffer storage you may need between the production of hydrogen and the production of a more or less continuous process to making ammonia or methanol or Fischer-Tropsch fuels or hot briquetted irons. So this could be in north of Europe, in Norway, where there is a lot of hydro potential and good wind, including offshore wind, which has now come lower in prices. So there are plenty of opportunities around the globe, in fact. But still, Australia, with its shared dimension, in some places with very good winds and of course exceptional solar, has a lot of possibilities. And again, I was very happy to hear Prof Garnaut express, as I did myself, that it makes more sense to export hydrogen-rich feedstocks and fuels, and that includes deoxidized iron, metal iron, than hydrogen as such, which is really tough and costly to move and to ships and store.